I'm Dr. Dwayne Rieger, and welcome back to GeoMapApp Tours. Today we're going to be looking at transform plate boundaries, another one of the three types of tectonic plate boundaries. And so first we're going to zoom in on the Mid-Atlantic Ridge to look at our first transform plate boundaries. So if you remember from our last tour when we talked about divergent plate boundaries, when they form along the seafloor, they form these mid-ocean ridges where new oceanic lithosphere is formed due to volcanism. But you'll notice that there are these offsets in the ridge itself. And what's happening is new seafloor is being formed at this ridge, and it's moving away from this ridge. And so where the offset in the ridge exists, you have this another type of plate boundary where the lithosphere that's being formed here is moving in that direction, is moving alongside the lithosphere here, being formed at this ridge and moving in that direction. So the plates are grinding alongside one another, moving along each other. So if we plot the locations of earthquakes, you can see that earthquakes don't only occur along the mid-ocean ridge, where rock is being pulled apart, causing it to fracture and fault, but earthquakes are also occurring along transform plate boundaries, where the rock is grinding alongside each other. So we have earthquakes occurring along this transform plate boundary. Now, notice that volcanism occurs along divergent plate boundaries, so along the ridges, but volcanism does not occur along transform plate boundaries. It's the only tectonic plate boundary where volcanism does not occur, transform plate boundaries. And so most transform plate boundaries are these little connecting segments between divergent plate boundaries. But not all of them are, I mean most of them, and some of them are found on land as well. If we zoom out, we can see some more larger transform plate boundaries in the ridge, these little jogs in the ridge. Zoom out even further, we can find a more infamous transform plate boundary that's actually found on land. And this transform plate boundary is a boundary that connects the divergent plate boundary here, that's the spreading ridge that's forming the Gulf of California, and this divergent plate boundary here, this is the Gorda spreading ridge. And so if we zoom in on this segment in between there, and if we plot earthquakes, you can see earthquakes running in a line along here. And what is this transform plate boundary? Now, some of you may have heard this transform plate boundary. It's known as the San Andreas Fault, and it's a fairly long transform plate boundary relative to most, and it does exhibit large earthquakes. However, like I said before, it does not exhibit volcanism. And there's other larger transform plate boundaries on land as well. If we zoom out and go to a different part of the world, we zoom in on Turkey, if you look, you can see this kind of line running along northern Turkey, where it looks like it's been kind of cut with a knife. Well, this line is offset in topography caused by rock moving along that line alongside each other. So part of Turkey is moving this way, part of Turkey is moving the other way. I'm not sure the motion exactly, it might be reversed, but they're moving alongside each other along this line. And we can, if we map the locations of earthquakes, we can see earthquakes occurring along that line. Okay, there are earthquakes in locations that aren't plate boundaries, but we do see these linear features along the line that marks the transform plate boundary. This is the Northern Anatolian Fault. So that's it for transform plate boundaries. Remember, most of them are relatively short and act as connecting segments between segments of mid-ocean ridges, but some of them are longer and found on land and exhibit large earthquakes, and no transform plate boundaries exhibit volcanism. Thank you very much, and hope to see you next time.